Hello, my name is Deniz Kaplan, and now I will be performing my physics 102 experiment. In this experiment, I will throw a little magnet inside this Cooper tube, and as you can see, it falls down with a constant velocity. This is because when I throw the magnet inside the tube, the velocity of magnet creates a induced current in the tube, and the induced current in the tube creates a reverse force to its weight, and it falls down with a constant terminal velocity. So it's actually it doesn't fall with a constant velocity, but it quickly reaches a very close value to its terminal velocity, and it seems like it is falling with a constant velocity. So in my theoretical calculations, I will assume that the ball is falling with a constant velocity and this tube is infinitely long, because these assumptions put a great ease on the theoretical calculations, and this ease is very important since the calculations are very complicated and long. Now I'm throwing the magnets inside the tube, and I will measure the time as it's fall. It falls down approximately in 6.5 seconds. Now, for my theoretical calculations, I will measure the length of the tube and the diameters of the tube, and use some properties special to Cooper and calculate the theoretical velocity and the experimental velocity. Sure. As you can observe, the length of the tube is 66.7 centimeters. Now I am measuring the outer radius of the tube. The outer radius is approximately 1.5 centimeters. And now I will measure the inner radius of it. Its inner radius is approximately 1.3 centimeters. In order to calculate the theoretical velocity, I have to measure some properties of the magnet. So, in order to calculate the experimental velocity, we need to know the magnetic moment of the magnet. So, in order to find the magnetic moment of the magnet, we need to find the residual magnetism of the magnet. So, it can be measured, the magnetism from the surface. So now I am measuring the magnetism. The magnetism value varies. It is not constant due to some errors associated with the I think other tools here, but it is approximately 0.266 Tesla. As you can see here, the diameter of the magnet is approximately 1.2 centimeters. Now I am measuring the mass of this magnet. It is 6.58 grams. In order to calculate the theoretical velocity, I need to know the conductivity of this Cooper tube. So, as you can see here, its conductivity is 6 times 10 to the 7 1 over ohm meters. So, when we put the values in the formula, in this formula, which I have derived, but I can't mention it here because it is too complicated to derive this formula, but further details will take place on my final report. So when I put the values on the formula, we found that the theoretical terminal velocity is 1 meters per second. So as you can remember, we measured the length of this tube as 66.7 centimeters, and we measured the falling time as 6.67 seconds. So, respect to these values, we also find the experimental velocity as 1 meters per second. So, our experiment presented a very decent and very valid solution. So, our experiment is successful.